Hi, welcome back to my class in Mathematics of Investment. For today, we will have another example for equation of values. But in this example, we have two equal payments to find. And so consider the following problem. Petra has the following obligations to pay. Letter A, 85,000 pesos with interest at 12% due in 2.5 years. Letter B, 135,000 pesos with interest at 15 and 1/4% compounded monthly due in 5 years. And letter C, 225,000 pesos with interest at 9% compounded semi-annually due in 7 years. Find the two equal payments at the end of 3 years and 6 years. If Petra agrees, of course, with the bank, with 8 and 3/4% compounded quarterly. Now, the two equal payments are to be made at the end of 3 years and 6 years. The first payment is to be made at the end of 3 years. And the second payment, which is equal to the first payment, is to be made at the end of 6 years. And so at the end of 6 years, all these three obligations will be settled. And the first step is to find the maturity values of each of the three obligations, beginning with the first obligation worth 85,000 pesos. This is the principal. With interest at 12%. It is not specified in letter A what type of interest is 12%, but we had an understanding in the lesson before that whenever the interest rate is not specified, it is understood it is taken as simple interest rate. Therefore, for the first obligation, we take 12% as a simple interest rate, denoted by I. And 12% in decimal number is 0.12, or 12 divided by 100 is 0.12. And first obligation together with the interest at 12%, simple interest, is to be paid at the end of 2.5 years. So this is your T, 2.5 years or 2.5 years. The maturity value of the first obligation is computed by using the following formula for accumulated value of principal P at simple interest rate. A is equal to P times quantity 1 plus psi P, where P is 85,000 pesos, simple interest rate in decimal number is 0.12, and T is the time 2.5 years. And we compute this value using our calculator, using your scientific calculator. And you start with 2.5 multiplied by 12 plus 1 and multiplied by 85,000. We have 2.5 multiplied by 0.12. Press equal sign in your calculator, plus 1. Press equal sign and multiply by 85,000 pesos. And you should get 110,500 pesos. This is the maturity value of the first obligation worth 85,000 pesos is 110,500 pesos due at the end of 2.5 years. And this amount includes the principal and the interest at 12% simple interest. And in the timeline, we will write this amount at the end of 2.5 years above the timeline. But first, we find the maturity value of the second obligation worth 135,000 pesos. The interest rate for obligation 2 is a compound interest rate because it says 15 and 1/4% is compounded monthly. And 15 and 1/4% compound interest is denoted by J. And we should write 15 and 1/4% in decimal number. 1 divided by 4 is 0.25 plus 15, that's 15.25%. And 15.25% you divide by 100 and you should get 0.155, 0.1525. Again, 1/4 is 1 divided by 4, 0.25 plus 15 is 15.25. And 15.25% you divide by 100%, you should get 0.1525. And the principal of 135,000 plus the compound interest rate, compounded monthly, that means M is 12, is to be paid at the end of 5 years. That is the maturity value of the second obligation, which includes the principal of 135,000 and the compound interest is to be paid at the end of 5 years. The maturity value of the second obligation at compound interest rate is computed using the formula for accumulated value of principal at compound interest rate. And the formula is given by capital A equals P principal times quantity 1 plus I to the power n, where I is the interest rate per month, which is equal to J divided by M. The interest rate per year in decimal number is 0.1525 and we divide that by 12 months to get the interest rate per month. And you may divide this 0.1525 by 12, but do not round it off yet to two decimal places because we will do the rounding off in the final answer. But you may leave this as is 0.1525 divided by 12. And the exponent n here is the total number of conversion periods, total number of interest computations in 5 years. If interest is computed 12 times a year. Hence, the total number of interest computations denoted by N is M multiplied by T. Hence, the total number of times that interest will be computed in 5 years is denoted by N, M multiplied by T. M, the number of times that interest is computed in 1 year, 12 times, multiplied by number of years, 5 years. And 12 multiplied by 5 is 60. Now, we substitute all the given information into this formula. Principal is 135,000 pesos. Again, we compute this value using our scientific calculator, but you start with the quantities inside. You start with 0.1525 divided by 12, press equal, plus 1, press equal, and then raise the answer to the power 60, press equal, and then multiply by 135,000 pesos. We do that. We start with 0.1525 and divide that by 12. Press equal, plus 1, press equal, and raise the answer in your calculator to the power 60. Press equal and multiply the answer in your calculator by 135,000 pesos. And you should get 288,002.85 pesos. Thus, the maturity value of the second obligation is 288,002.85 pesos. This is to be paid at the end of 5 years. And this amount includes the principal of 135,000 pesos plus the compound interest at 15 and 1/4% compounded monthly. Next, we will compute the maturity value of the third obligation. The third obligation is worth 225,000 pesos with interest at 9% compounded semi-annually. And the principal plus the interest is to be paid at the end of 7 years. Thus, the principal fee is 225,000 pesos. The compound interest rate denoted by J is 9% and divide by 100, 9% the decimal number is 0.09, and this interest rate is compounded semi-annually, which means that interest will be computed twice, 2 times in a year, every 6 months for 7 years, because the principal plus the interest is due at the end of 7 years. And the maturity value of this loan or principal of 225,000 pesos is computed using the formula for accumulated value of principal at compound interest rate. Now the formula for the accumulated value of P at compound interest rate is given by this formula, capital A equals principal times quantity 1 plus I to the power n, where I here is the interest rate per conversion period. For this example, conversion period is 6 months. Interest will be computed every 6 months, And the interest rate every 6 months is computed by, denoted by I, is equal to J divided by M, where J is the interest rate per year of 9% or 0.09 divided by 2. And we divide 0.09 by 2 using our calculator. And you should get 0.0045. Let us check. 0.09 divided by 2. You should get 0.045. And the exponent n is the number of times that interest will be computed in 7 years. And it's denoted by n, and it's equal to m multiplied by t. The number of times that interest will be computed in 1 year multiplied by number of years, t. M is 2 and t is 7 multiplied by 2 equals 40. Now we are ready to substitute all the given information into this formula. Principal is 225,000 pesos. And we compute this quantity using our calculator. We start with 0.045 plus 1, that's 1.045. And raise that to the power 14, press equal in your calculator, and multiply the answer by 225,000 pesos. We have 0.045 plus 1, press equal, and that answer raised that to the power 14. Press equal and multiply the answer by 225,000 pesos. And you should get 416,687.61 pesos. Thus, the maturity value of the third obligation, that includes the principal and the interest, is 416,687.61 pesos. And this amount is due at the end of 7 years. And we plot this amount at the end of 7 years. We write here 416,000. And you can also see that I have already plot the first two maturity values of the first two obligations. The first obligation has a maturity value of 110,500 pesos due at the end of 2.5 years, which is between 2 and 3 years. And the second obligation has a maturity value of 288 and 2.85 pesos due at the end of 5 years. Now we are asked to find the two equal payments due at the end of 3 years and 6 years. And since these equal payments are unknown, we represent these equal payments by a variable. And I will use the variable x. We let x be the amount of two equal payments. And the two equal payments are due to be paid at the end of 3 years and 6 years. As we said in the lesson before, the maturity values are written above the timeline and the payments are written below the timeline. So we plot the first payment x at the end of 3 years. And we plot the second payment, which is equal to the first payment and is also denoted by x at the end of 6 years. And that's it. That is the first step. You find the maturity values of the obligations and you plot them in the timeline by writing them above the timeline, and you represent the payment by a variable and you write the payment or the equal payments below the timeline. The next step is to choose a comparison date. A comparison date can be any point on the timeline. And I will take the end of 4 years as the comparison date. The next step is to find the values of these amounts or maturity values at the comparison date. If the amount is before the comparison date, we have to accumulate that amount. If the amount is after the comparison date, that means we have to discount the amount. And we start with the value of 110,500 pesos at the comparison date. Because 110,500 pesos is due at the end of 2.5 years. This is 2.5, which is a time before the comparison date. That means we accumulate 110,500 pesos at the end of 4 years. And we accumulate 110,500 for how many years? For 4 minus 2.5, that's 1.5 years. Four minus 2.5 is 1.5 years. We will accumulate 110,500 pesos at the end of 4 years for 1.5 years. And to accumulate an amount is to find its accumulated value. And since Petra agrees with the bank to pay 8 3/4% compounded quarterly, we will find the accumulated value of 110,500 using the formula for accumulated value of principal at compound interest rate. And this is the formula for accumulated value at compound interest rate, where I here is the interest rate per conversion period, which is equal to J divided by M. And J is the given interest rate per year, which is equal to 8 3/4%. And M is the number of times that interest will be computed in 1 year. And it says that 8 3/4% is compounded quarterly, which means that M is 4, which means that interest will be computed 4 times a year, every 3 months. We write J, 8 3/4%. Divide by M. For quarterly, M is 4. But we have to convert 8 3/4% to decimal number. 3/4 is 3 divided by 4, it's 0.75 plus 8, that's 8.75%. Divide that by 100% and you should get 0.0875. And we divide that by 4. If you divide this, if you convert this to decimal number, do not round it off yet because we will do the rounding off in the final answer. But you can leave this as is. Next, we need n. N is the total number of times that interest will be computed for t years. And n is equal to m multiplied by t. And 8 and 3/4% is compounded quarterly, which means that m is equal to 4. And we want to find the accumulated value of 110,500 for 1.5 years, or t equals 1.5 years. And 1.5 multiplied by 4 is 6. If we want to accumulate 110,500 for 1.5 years, 110,500 is our principal. And A now is equal to and we compute this value using our scientific calculator. We start with 0.0875 divided by 4, press equal, and then to the answer you add 1, press equal, and the answer you raise to the power 6, press equal, and the answer multiplied by 110,500. We do that using our scientific calculator. We have 0.0875 divided by 4, press equal, and you add 1, press equal, and the answer raised to the power 6. Press equal, and the answer multiplied by 110,500. And you should get 125,819.78 pesos. Next, we find the values of 288,000 and 2.85 pesos at the comparison date. And since this amount is after the comparison date, that means we will discount 288,000 and 2.85 pesos for 1 year. We discount 288 and 2.85 pesos for 1 year. 1 year is 5 minus 4, 1 year. And to discount an amount is actually to find the present value of 288,000 and 2.85 pesos. The present value of 288,000 and 2.85 pesos is an amount that is lower than 288,000 and 2.85 pesos. And after we do that, we also find the value of 416,687.61 pesos at the comparison date. And to find the amount, this amount at the comparison date is also to discount this amount at the comparison date for 7 minus 4, 3 years. We also discount 416,687.61 pesos at the comparison date. For how many years? For 7 minus 4, 3 years. And to discount this amount is to find its present value, which is an amount lower than 416,687.61 pesos. And we will use the rate that Petra agrees with the bank, 8 3/4% compounded quarterly. Find the discounted value of the second maturity value of 288 and 2.85 pesos. And we will discount this amount for 5 minus 4, 1 year. And to discount this amount is to find its present value, which means that we take 288 and 1,000 and 2.85 pesos as the accumulated value. And the formula to find the present value is given by A times quantity 1 plus I to the power negative n. This formula, as we have shown in the lesson before, is obtained from the formula for accumulated value. A equals P times quantity 1 plus I to the power n by dividing both sides by quantity 1 plus I to the power n. And you will get P equals A divide by quantity 1 plus I to the power n. And if you bring 1 plus I to the power n to the numerator, you have to take the opposite sign of the exponent of 1 plus I to the power n. That's why we have negative n in the exponent of 1 plus I raised to negative n, where I is the interest rate per conversion period. As we have shown earlier, it is equal to the interest rate per conversion period denoted by A is equal to J, the given interest rate per year, 8.8 3/4%, excuse me, or 0.0875, divide by M. The interest rate is compounded quarterly, so M is 4. And N is equal to M multiplied by T. Where M is equal to 4, the given compound interest rate is compounded quarterly. But for the second maturity value, T is equal to 1 year because we will discount 288,000 and 2.85 pesos for only 1 year. 5 multiplied by 4, 1 year. Hence, 4 multiplied by 1 is 4. Excuse me. And we compute this value in our scientific calculator. Again, we start with the quantity 0.0875 divided by 4. And the answer in your calculator, you add plus 1, you add 1 and press equal. And the answer you raise to the power negative 4. Press equal and the answer multiplied by 288,000 and 2.85 pesos. And you should get an amount lower than 288,000. We do that. We have 0.0875 0.0875 divided by 4. Press equal, and then you add 1, press equal, and the answer in your calculator raised to the exponent negative 4. Press equal, and the answer in your calculator multiplied by 288,000 and 2.85 pesos. And you should get 264,122.68 pesos. And you can see that the value of 288,000 and 2.85 pesos at the comparison date is an amount lower than 288,000 and 2.85 pesos. And it is the present value of 288,000 and 2.85 pesos. Or it is the discounted amount of 288,000, 2.85 pesos. And if you want to check, you accumulate this amount for 1 year at 8 3/4% compounded quarterly. Next, we find the value of 416,687.61 pesos at the comparison date, which means that we discount this amount for 7 minus 4, 3 years. And to discount this amount at the comparison date for 3 years is to find its present value. Again, using this formula, P equals A times quantity 1 plus I to the negative N. Where A now, the amount to be discounted is 416,687.61 pesos. And the interest rate per conversion period is the same, 0.0875 divided by 4. But now N will change because P has changed. For T equals 3 years, the total number of interest computations is M multiplied by T, where M is 4 for quarterly, and T now is 3 years. 4 multiplied by 3 is 12. We now compute the discounted amount or present value of 416,687.61 pesos using this formula. And we compute this value in the calculator. You start with 0.0875. Divide that by 4. Press equal, plus 1. Press equal, and raise that answer in your calculator to the power negative 12. Press equal, and the answer in your calculator multiplied by 416,687.61. And you should get 321,393. And this is the discounted amount of 416,687.61 pesos. Or this is the present value of 416,687.61 pesos. And if you want to check if this is correct, take this as the principal and accumulate it for 3 years. 8 3/4% compounded quarterly, and you should get 416,687.61 pesos. Now we have found the values of the maturity values of the three obligations at the comparison date, which is the end of 4 years. Now we find the values of the two payments at the same comparison date, the end of 4 years. The value of the first payment, X, which is unknown, is at the comparison date is obtained by accumulating X for 1 year. To find the value of the first payment at the end of 3 years at the comparison date, we accumulate X for 1 year. 4 minus 3 is 1 year. And if we want to accumulate X for 1 year, we take X as our principal. A now is equal to X multiplied by quantity 1 plus I, where I is the same 0.0875 divided by 4. And N is equal to M multiplied by T, where M is 4, and T is 1 year. M is 4 and T is 1 year equals 4. We accumulate X at the end of 4 years. From 3 years, T is 1 year, 4 minus 3 is 1. So N is M multiplied by T, M is 4 and T is 1. N is 4. And we compute this quantity. We take all the decimal numbers and multiply by X. We have 0.0875 divide that by 4, add 1, and the answer raised to the power positive 4. And that answer in your calculator, do not round it off yet to 2 decimal places, multiply that by X. And you should get 1.09041319,284 multiplied by X. This is the value of the first payment at the comparison date, except that we do not know yet what is X. Next, we find the value of the second payment due at the end of 6 years at the comparison date. Since this second X is due at the end of 6 years, which is a time after the comparison date, that means we have to discount X. To find the value of X at the comparison date, 4 years, we have to discount it for 6 minus 4, 2 years. And to discount X for 2 years, again 2 years is X. 6, 2 years is obtained by subtracting from 6, 4. 6 minus 4 is 2 years. We will discount X, the second payment, at the end of 6 years for 2 years to find its value at the comparison date at the end of 4 years. And to discount X for 2 years is to find its present value using this formula, because the given is compound interest rate and the interest rate per period is 0.0875 divided by 4. Using the formula for finding the present value at compound interest rate, P equals A times quantity 1 plus I to the negative n, where the amount we want to discount is X. The amount to be discounted is taken as A, and A here is X. Multiplied by quantity 1 plus I is 0.0875 divided by 4 to the power minus n. For the second payment, n is m multiplied by t, where m is 4, because the given rate is compounded quarterly, and we want to discount the second payment x for 2 years. 2 years is x minus 4, 2 years. Hence, n is 6, and the exponent minus n here is negative 6. And again, we find this value in the calculator, and the answer in your calculator multiply by x. .0875 divide by 4, press equal, add 1, and the answer in your calculator, you raise to the power negative 6. Press equal, and the answer in your calculator multiplied by x. And you should get 0.87824028416 multiplied by x. Now we have found all the values of the maturity values at the comparison date. We have also found all the values of the payments at the comparison date. We are now ready to write the equation of values. For you to remember the equation of values, at one side of the equation of values, you have the sum of obligations, and the sum of the obligations should be equal to the sum of payments at the other side of the equation. But these obligations are actually the values of the maturity values of the obligations at the chosen comparison date. And these are the values of the maturity values of the obligations at the comparison date, which is the end of 4 years. The first obligation with the computed maturity value has a value at the comparison date of 125,819.78 pesos. And the second obligation with the computed maturity value has the value of 264,122.68 pesos at the comparison date, which is the end of 4 years. And the maturity value of the third obligation has a value at the comparison date of 321,343.65 pesos. And the sum of these values of the maturity values of the obligations is given by 128,819.78 plus 264,122.68 plus 321,343.65 pesos. And the sum of the obligations should be equal to the sum of the payments. And the values of the payments at the comparison date, there are 2 equal payments, both denoted by X, and they are due at the end of 3 and 6 years respectively. And their values at the comparison date are given by this. 1.0904131984x is the value of the first payment due at the end of 3 years at the comparison date. We accumulated x, the first payment, for 1 year. And this is the value of the first payment at the comparison date. And to this value of the first payment at the comparison date, we add the value of the second payment due at the end of 6 years at the comparison date. And this is the value of the second payment at the comparison date. 0.87824028416 multiplied by x. And we add these values of the payments at the comparison date. And the sum is the other side of the equation of values. We have 1.090413192884x plus 0.87824028416x. And the sum of the left hand side is equal to 711,286.11. And the sum of this other side of the equation, we add the numerical coefficients 1.090413192284 and 0.87824028416, and you should get the sum of 1.968653477, and copy the common literal coefficient x. And from this equation, we solve for x by dividing both sides by the coefficient of x from the left-hand side. 711, 286.11, we divide by 1.968653477. And if we divide the left-hand side by 1.968653477, this number divided by the same number is equal to 1, and we are left with x at the left hand side. And finally, x is the quotient when you divide 711 286.11 by 1.968653477, and the value of x is 361,305.91 pesos. This is the amount of each payment to be made at the end of 3 years and 6 years. At the end of 3 years, Petra will have to pay 361,305.91 pesos. And at the end of 6 years, Petra has to pay the same amount of 361,305.91 pesos. And all her 3 obligations will be settled. For your practice, please try the following exercise. Pedro has the following obligations to pay. Number 1, 30,000 pesos due in 1 year without interest. Number 2, 48,000 pesos due in 2.5 years with 11% simple interest. And 3, 59,000 pesos due in 4 years with 8.25% compounded quarterly. Find the 2 equal payments due at the end of 1.5 years and 3 years. If Pedro agrees at 14.75% compounded monthly. For this problem, take 2 years, the end of 2 years as comparison date. And that completes our lesson for today. If you have question about the lesson today, you ask your question in the comments below. But don't forget to subscribe to my YouTube channel, Art Calison, the channel of learning and leisure. Thank you for joining me in my class today in Mathematics Self-Investment.